This is a deep dive into observability in a box, covered by Tejo Prayaga, who is head of AIOps product and marketing, and also covered by Funny Penmatsa, head of solutions engineering. Hi, welcome to this session on observability in a box. I am Tejo Prayaga, head of AIOps product management and marketing at CloudFabrix. Later in the session, we will be joined by my colleague Funny Penmatsa, who is the head of solution engineering at CloudFabrix. In this session, what we will do is first, I will provide a brief introduction and overview of observability solution. And then Funny will do a deep dive covering demos and various use cases that we can address with observability in a box. Introducing CloudFabrix Observability in a Box. This provides unified observability to edge, on-premise, and cloud environments by leveraging artificial intelligence at the edge, closer to the source of data. And it is built using open source technologies and OpenTelemetry. So why did we build this solution? If you look at some of the challenges with traditional monitoring implementations, there are visibility gaps with cloud native workloads and microservices based applications. And there is limited extensibility due to rigid architectures. And we are also seeing high operational costs to maintain and implement these solutions. Observability in a box addresses these challenges. It provides end-to-end observability, which means metrics, logs, and traces all provided in a unified solution. And then it provides AI inferencing at the edge, closer to the source of data. It also provides asset discovery and topology context. And it is all built using open source components. And it is applicable to your on-premise, edge, and cloud workloads. What does it provide? The first thing is it provides a observability unified pack so that you can continuously monitor your IT environments. You can collect and ingest any kind of IT logs, and you can do complete end-to-end request tracing of your application workloads. And here we are using some of the open source components. And the next, it provides AI inferencing at the edge. So you can detect anomalies, you can detect the seasonality in the baseline utilization of your IT applications and workloads. You can also do predictive analytics. And here we are using our own CloudFabrix AI engine to provide this inferencing. Next, we also provide asset discovery and application dependency mapping, where we are using agent-less mechanism to quickly and rapidly discover your IT applications and workloads. And we also build a topology context and application dependency mapping to provide holistic context to IT operations data. And here we are using our own asset intelligence modules and edge collector. Finally, we are also packaging here something called CloudFabrix Data Exchange, which is both a data integration architecture and a utility to help accelerate data integrations and enable faster movement of data in and out of the observability solution. So what exactly is in this box? For metrics and monitoring, we are using Grafana and Prometheus components. For logging, we are using Elasticsearch and Kibana. And for tracing, we are using Jaeger and OpenTelemetry. And rest of all the components that you see here are CloudFabrix purpose-built native components. So we have the asset discovery and mapping using the edge collector and the asset intelligence modules. We are bringing in our own AI ML engine to the edge. And on top of all of this, we have packaged this data exchange CFXDX, which allows rapid integrations and faster movement of data in and out of this observability solution. So with that, I'm going to hand it over to Funny, who will be doing a deep dive into this particular solution, doing some of the live demos and covering some of the use cases. Okay, thank you.
Thanks, Teju. Hi, everyone. I am Funny Pinmetsa, and I lead solutions engineering and architecture at CloudFabrix. Thanks for joining this technical deep dive session on CloudFabrix observability in a box solution. During the next 45 to 50 minutes, I'm going to demonstrate what CloudFabrix observability in a box solution is, what it contains, what it does, and how things work. So we have prepared a sample demo application stack for the purpose of this demo. So part of the solutions, metrics, logs, and traces along with alerts are fundamental and foundational modules within our observability solution. I'm going to cover these modules along with the CloudFabrix advanced AI module, which is called as CFX Edge AI, asset discovery module, and reporting. Go to the next slide. So let me quickly walk through the demo environment that we have. So we have created a sandbox demo environment with a sample Spring Framework-based Java application stack called Pet Clinic, which is hosted on a virtual infrastructure. So this application stack is running inside a container on a Linux machine with a 3-tier architecture. It has a web service, app service, and database service, along with underlying hosted virtual infrastructure components. So this Pet Clinic application is primarily monitored by our observability in a box solution end-to-end in this demo environment. Within our observability solution, we use agents to collect metrics, logs, traces in real time from these application stacks components. Additionally, we also collect the metrics, logs, information from the underlying virtual infrastructure as well. With that, let me jump into the demo environment. Let me open the Pet Clinic application using a browser. Okay, let me open a browser tab here. Type petclinic.com, running on port 8080. Okay. So this is the sample Pet Clinic application UI. So this application is primarily for Pet Clinic users to track pet owners, pet veterinarians, doctors, clients, and their pets. So as I mentioned briefly, the entire stack, this application stack being monitored by our observability box in a solution. So with that, let me open our observability management dashboard. Let me go to the tab here. I address. Okay. So what you are seeing here is our observability solution with a unified view of different components here. We have metrics, logs, and traces management modules, along with our asset discovery module, and most importantly, our Edge AI module. And we have here alerts view, where using which you can see what are the current active alerts. Our AGIA module, even though it doesn't have a UI, as it's not showing up here because it doesn't have UI, but it runs in the backend as a service. And additionally, we have a reporting capability to generate reports for asset inventory, alerts, and metrics and logs for monthly, quarterly, or yearly assessment. With that, let me go back to our apps view. Let me go to the metrics view here. When I click on the metric, it launches our very intuitive metrics UI. Within that, we have created a specific dashboard for the demo pet clinic application here. We click on the pet clinic application dashboard here. So what we have here is, it is a unified dashboard covering different dimensions of availability, capacity, and performance KPIs of entire pet clinic application stack in a single pane. Having all of these different KPIs from availability, capacity, and performance metrics visualization dashboard, it will help to visualize how the application is performing in real time. Is it available, and how its resources being consumed and whatnot. So within this, all of these charts, let me quickly walk you through. So if you can see here, the capacity metrics, capacity resource information like CPU cores, number of CPU cores it has, amount of memory it has, and the file system, the configured file system, how it's being used. What is the current state of CPU and memory utilization? From availability perspective, what it is showing here is pet clinic application availability is up by monitoring the URL of the pet clinic. So the URL is the petclinic.com running on port 8080. So it is monitoring this URL and showing the real-time status of whether it is up or down. And also it is monitoring and the URL and providing the status code of the availability. So this is HTTP code. So 200 means it's good. So it is showing as green. And here we have AI applied CPU application usage summary. I'll come back to you this in a minute when I talk about our CFX Edge AI module. Meanwhile, let me walk you through the other metrics for the pet clinic application. So the way I put together this dashboard is how the application resources from CPU memory network being utilized here, the CPU usage of pet clinic camp versus how the underlying hosted infrastructure like Linux and operating system, how the overall the CPU looks like compared to application, right? So here, similarly, we have the pet clinic app memory usage versus the total amount of memory being consumed on the host, the network traffic, and the disk metrics. So it is a very flexible and customizable dashboard, and it allows you to create, edit, delete, templatize the dashboard with different metric visualization as per the need. And it also allows you to export, import between multiple environments. So let me show you what I mean by that. So let's say if you wanted to add additional visualization chart here. So within this dashboard view, it will allow you to click on add panel here and click add new panel. So this is the visualization definition view. Here you have different options. This is the visualization output view. Depends on the what type of chart you wanted to select. On the right side, you have the different options, like which visualization chart you wanted to select, like a graph for time series data, and you have the gauge, and you have the tabular heat map. So these are some of the out-of-the-box visualization charts available for the metrics view. And then here, our metrics backend component is Prometheus. So if you wanted to query the backend time series data, in this case, CFX Prometheus, here, what it supports is the Prometheus query language. So if you know the metric, you can type in the metric and it automatically pulls in the time series data and allows you to visualize and define the chart the way you need and the way you want it to be presented. So let me take a quick example. For example, I'm interested in node CPU seconds total. Refresh here. So this is one of the metric is coming from a Linux operating system. So what it is getting us is it is querying the backend, which is a Prometheus, and querying this particular metric, node CPU seconds total, and which is associated with all of the Linux operating system endpoints. Right? If I highlight this chart here, it is showing this metric is coming from a lot of endpoints, as you can see, 1095, 121, 206, 124.111, and you have other hosts, right? And then within this metric, I'm interested in monitoring a particular Linux operating system endpoint. So I'm picking 1094, 1095, 124, 111. Now it limits the scope to only this particular node. Let me refresh here. Yeah, if you see this here, yeah, it's limited to only the scope. Within this, let me see what are the other parameters available to further filter down. So let me pick mode. So what are the options we have here? So let me select system. So within the CPU usage utilization, it is providing different options, subparameters, which it is monitoring, like system usage, user application usage, as far as CPU is concerned. So when I apply it, I'm filtering it down to this particular 124.111 Linux OS, and I'm filtering further down to the system parameter, which is one of the CPU metric, sub CPU metric. So this is how you can create your own visualization. So it is very flexible, very extensible, and from our agents, they provide very extensive such metrics. There are tons of them. I can give one example here. Let me connect to one of the agent. Let me type the code here. It is pointing to the agent that is running on this node, and if I click on metrics, so these are some of these very extensive metrics which the agent is in real time monitoring on that particular node and reporting back to the Prometheus backend. So for example, if you see node CPU seconds total, so you can see here within this metric, it is collecting it is a 8-core CPU system, and it is collecting the CPU metric from all of the cores, and within each core you have the sub CPU metric like idle time and IO wait time and whatnot. So this is pretty extensive, and these agents are available for different operating systems, applications, and infrastructure elements like compute, network, and storage, on-prem or public clouds like AWS or Azure cloud in cloud-like infrastructures. With that, let me show you what are the components available within the metrics module. Let me open a CLI. Let me connect to our observability machine. Okay, so I logged into our observability machine, and we have a CLI, CFX OIB. If I press tab, what you can see here is our observability CLI. We have these CLI options, which provides a lifecycle management operations like installing the components and uninstalling, and checking the status of installed modules. So let me type status. So it is providing what are the different observability modules that have been installed on this box. So what we have here is infra monitoring services, which are basically providing the metrics capability. So as we are talking about metrics here, and these are the some of the default components, which will be deployed part of our observability solution. So Prometheus is one of the time series backend, which collects the metrics and maintains the historical time series database. And Alert Manager is the alert management module. And the Grafana provides the visualization. So the UI, which I was talking about, where you can create your own dashboards and create your own visualization. So that is coming from Grafana module. And SNMP, Blackbox, Azure, these are the different exporters which allows you to monitor your network infrastructures like switches, routers, firewalls. And the Blackbox exporter allows you to monitor likes of URL monitoring, port monitoring, ICMP availability monitoring, and Azure allows you to monitor your cloud infrastructure. So similarly for other environments, we have other exporters which can be installed on demand as needed basis. And so that covers about the metrics modules. And with that, let me go back to the observability UI dashboard. Okay, here. Now let me talk about events and logs and how we are collecting the pet clinic application stack logs in real time. Let me click here. It is opening the log dashboard. Okay, what we have here is the pet clinic app events log dashboard. Let me click on that. Let me change the time window here, 15 minutes to 15 days. Click on update. Okay. So this is the log events coming from Pet Clinic application stack environment. So our observability solution, what it is doing is it is additional to metrics. It is also collecting the logs from this Pet Clinic application stack and from the underlying infrastructure components. So one of the key thing is these logs can be either structured or unstructured, and they can follow different formats. So what our log monitoring module provides is an ability to normalize the incoming logs with a standard format based on your requirement. It also allows you to add application-specific or environment-specific custom attributes using which you can create different visualizations, like you have here different pie charts based on the event types. And it also allows you to analyze and troubleshoot any application or infrastructure specific issues. So let me show you what I was talking about. So if I click on here and click on the discover, let me show the raw log events that are coming from Pet Clinic application and underlying syslog messages. So here, what you're seeing is these are all the log events coming from a Pet Clinic application. So these are the application event logs. So if I click on this, the latest one, and it gives you the details of the actual raw record and as well as all the metadata of these log record, right? So the metadata contains the timestamp when this event has occurred or when the event is ingested and where it is coming from. And which agent is basically monitoring these application logs and generating these log events, and what is the agent version and what is the event message, right? So this is application exception, as you can see, and it is also dissecting or I would say extracting the event type from the raw message. So as you can see here, this event message has a timestamp and severity of this event, its error. So it is extracting and it is populating as an event type. And it is also providing the host name of the source machine, which is generating, and what is the log path of the application. So in this case, these logs are being generated from Pet Clinic application. So additional to this, let's say if you wanted to tag any event that is coming from this particular host or coming from these logs, you can add your own custom attributes that will help you to apply those filters while creating the visualization, and while if you wanted to troubleshoot all of the application components which belongs to a particular application together in a single place. Let's go back to the dashboard here. Okay, so coming back to the pet clinic application logs. So here, the way we have created this dashboard is these events are coming from pet clinic application, and the right side, these are coming from the hosted infrastructure, which is basically the Linux operating system. So from the application, you can see these are the different types of events it has generated over the last 15 days. And if you're interested in, you wanted to look at and filter down only errors and warning. So the way you can do is you can just click on the error. So it applies the filter, and it shows you all of the error log messages for the past 15 days from this pet clinic application. Additionally, it also provides the query language. You can apply a different query parameters here to be able to filter down and look if you're looking for a specific event message. Or else you can use this advanced query language here. I'm interested in looking at both errors and warnings at the same time. So I can type this query. It automatically applies and filters down to all the errors and warnings. With that, let me quickly show how our observability solution quickly monitors the incoming logs in real time, and how it can populate into this dashboard. So with that, let's go back to the pet clinic application UI. Okay, let's click here. So there is an option to simulate an error message here. Before that, let me open and do a tail on the pet clinic log. So this is where the pet clinic application is running. Okay, I'm tailing the pet clinic application logs here, and I'm going to click on this error. And what it does is it generates an error message. So it has generated an exception here, as you can see. And let's go back here, and let's go back to this log analytics dashboard and see if it has seen the error message. So the previous latest one was at 1955. So let's refresh. Okay, so as you can see here, as soon as there is an exception generated by the application, our agent is monitoring these log the log sources in real time and processing and pushing it to our observability solution. So if you wanted to get an alert notification, you can create an alert rule within our observability solution, and based on this event type and certain criteria, it can generate an alert notification and send it to our AIOps solution. Additionally, what it allows is it allows you to define your own visualization chats here. For that, if you click on Edit Dashboard and click on New, and so what we are doing here is we're trying to create a new visualization. So what are the different options here? So we have the pie chart and the metric-based count chart, gauges, heat maps, and other options. And you have the region geo maps based on the longitude, latitude coordinates. With that, let me log into our observability solution. And let me show you part of our observability solution. What are the modules? What are the components which it provides for log monitoring solution? So let me do CFX OIB-status service log monitoring. And it shows what are the modules installed. So part of this, we install Elasticsearch, which is the backend storage for maintaining incoming log messages, both from active and time series. And a logstash component, which allows you to format and understand and normalize the incoming log message to a standard format. And Kibana is the visualization component. Curator is the lifecycle management for our Elasticsearch backend database, which allows you to take for backup and recovery if you wanted to purge any of the historical indexes, and if you wanted to create any aliases for your existing indexes. So Curator is the service. Alert is the alerting module for our log monitoring solution. So these are the components we install part of our log monitoring solution within our observability in a box. With that, let me go back to our observability management UI. And so far we have covered both metrics and event logs. Let me click on the traces. Okay, so what we have here, so it is a Agger-based UI for visualizing and analyzing application performance or functional issues using distributed tracing capability. So what is distributed tracing? Tracing or distributed tracing is interchangeably used in APM landscape. So distributed tracing is primarily refers to the multi-tier or microservices-based application architectures. So let's go back to the pet clinic applications that we deployed for this demo. So what I wanted to demonstrate here is while our agent is deployed and embedded part of the pet clinic application to capture the traces, I would like to make a quick transaction on this application. And after this, I will show you how our OpenTelemetry based agent captures all of the transactions from the start to begin. Let me click on adding an owner. So what I'm doing is I'm adding a new owner details. We type the city and the phone number. What I've done is I've added a new pet owner here on this application. Now let's go back to our trace UI. And under the search, I'm going to select the pet clinic application. And what the type of operation I wanted to select. So it is a, I'm making a change. I made a change to the application by adding a new record. So let me click the post and select find traces. So within last few minutes, I made a transaction. So it captured that trace and created 4 spans here. So let me click on this one, or you can click on this bubble here as well. So what we have here, right? So here we have the entire transaction trace. So before I jump into the details, I briefly want to touch upon the anatomy of a trace or distributed trace. So primarily, there are 3 components within this end-to-end trace. One is the trace itself, which represents an end-to-end transaction, and which consists of one or more sub-transactions within that the entire transaction, right? So the subcomponents are referred as spans. So this has 4 spans: the parent and the 3 childs here. And pet clinic execute is the parent span, and then we have the subspan. So what they represent is the individual hops from point A to point B, or point B to point D, and final destination, right? So when I click on the pet clinic post, so this is the post call, the API call, which is making to the application server, and finally the application server making backend call using Java JDBC connection, right? So, and the third important attribute of the distributed trace is the tags. So tags provides the metadata information of the trace, which helps the user to contextualize the created span. So when I click on the tag, so it will provide details, the metadata information about the trace. So this trace, this span is coming from which component and where it is going to. So it is making a call to backend to in-memory database and committing the transaction. So it also provides a different visualization if you wanted to analyze the traces. So these are some of the options here. When I click on the trace drop down here, if I click on the trace graph, so this is the multi-hop flow from start to end. And so we have few knobs here. Let's say within this transaction where it spent more time. If you click on time here, it highlights relative to the entire end-to-end transaction where it spent more time, and it is just highlighting the second and third step. It relatively spent more time to complete the transaction. So if I hover the mouse here, it took around 11.24 milliseconds here, 10.23 milliseconds. So how it captures the traces, right? So within the APM landscape, there are there's something called instrumentation. So there are two types of instrumentations available. One is manual, and the other one is automatic. And so when we talk about manual instrumentation, what we're talking about here is it requires a code change to the actual application. But it has its own advantages, like it's very flexible and it gives full control to the application developers. And they can add the necessary code where needed to start and finish the span. And also it will help the application developers to give the full control, and these are some of the benefits. And also it can be less noisy because application developers are particularly choosing what they wanted to capture part of a transaction. So other one is the automatic instrumentation, right? So automatic instrumentation doesn't require any changes to the underlying code of an application. So it just uses the standard out of the box. So in our case, we're using OpenTelemetry. So it uses the OpenTelemetry agent, whatever it provides, and supports the standard functionality for either a Java-based application, Python, .NET or Go, whatever. It provides out-of-the-box capability. All the user need to do is they just need to load this agent along with the application while running, and it automatically captures the application transaction inside the stack or in a distributed stack. So with that, let me quickly show in the CLI. So going back to where the observability is running and the pet clinic application. Let me look for pet clinic container ID. Let me go inside the container. I just want to show how the OpenTelemetry agent is embedded part of the pet clinic application. So in this, for this purpose of the demo, we have chosen automatic instrumentation. Okay, I'm inside the pet clinic application container. So if I run this command, this shows the running application process, which is the actual Spring-based pet application. So as you can see here, this is the actual application jar file. And what we have done is, while loading this Java application, we have embedded this open tracing. It's a OpenTelemetry compatible jar, and that's pretty much it. So right, so then it automatically it does the job of collecting the traces, and it sends all of the traces to the collector, which is running within observability machine. So here it shows what is the target endpoint. So this is where it is sending all the traces to. And so we use the OpenTelemetry agents, and it is compatible. It is available for wide variety of well-known applications like Java, Python, .NET, and Go. And I can quickly point you to some of the open source documentations here. However, you can always feel free to get in touch with us. We'll be able to help you. So this is available on the GitHub, and this is for supporting the Java application. From here you'll be able to download the agent, and it has extensive documentation. And similarly, so we have the OpenTelemetry supported package for Python as well. So with that, let me quickly go back to the observability dashboard here. So far we have covered metrics, events, logs, and traces, which are the foundational pieces of the our observability solution. Now let me go back to the slides here, and I wanted to specifically talk about our AGAI. Click on this slide and present. So CloudFabrix AGAI module is part of our observability solution. So our AI module applies machine learning algorithm to metrics, logs, and traces, which are being collected within our observability solution to find the patterns of the behavior, identifying the seasonality, and plotting the baseline for lower bound and upper bound, and to elevate the anomalies, right? So that you can get a notification if there is any anomalies detected. You can create alert notification based on that. So by doing this, what it helps is it can reduce the alert noise significantly at the source itself. Unlike traditional way where if there is a static-based thresholds, like okay, if the CPU usage is 70% or more than 70%, I want to generate an alert. So that's a traditional approach, right? So what if there is an expected CPU spike because of there's a scheduled backup job or a application job which is running, which is expected to run either end of the day or after business hour or once in a week. So those are the expected behaviors. So the static thresholds, blindly, as soon as they see the CPU spike, they send an alert, right? So even though it is expected, we expect that the CPU to go up because of the there is a job, or there is a particular operation which requires some more resources. What if there is a standard operation within your environment, and you don't want to get notified and create a false alarm, right? So using our AI module in applying this machine learning algorithm. So within our solution, what we use is the Facebook Prophet ML library, which is very, very popular and proven in the industry for regression analysis. So this is the module, machine learning algorithm module that we use within our solution. So by applying this on the key KPIs, key KPI metrics, by creating these baselines, understanding these patterns of what is expected, what is not expected. So it's in ML terms, it's called as seasonality. So it understands the seasonality of end of every day, or once in a week. It is expected that the CPU is going to up, right? So based on that, it understands the pattern. Instead of raising the alert, it just assumes that it is expected, right? Based on the historical data. And once it gets enough historical data to have an understanding to create the baseline, and you have the ability to create a anomaly factor. So if anything goes beyond these standard baseline, or upper bound or lower bound, we are talking about upper bound here, for example. Anything goes beyond the factor of 0.5x or 2x or 3x. You can define that, and the system automatically treats that as an anomaly, and it generates an alert. So that way, it reduces the typical alert noise significantly at the source itself. So let me explain briefly the flow here. So here we have, as in this slides, it is depicted. We have the CFX AI module. What it is doing is using our CFX DX library, which is the data exchange library. which integrates with both backends of our observability solution, which are Prometheus and ES. What it is doing is it is collecting the historical data, if it is metrics from Prometheus, if it is a log volume from ES, and doing this regression analysis and re-ingesting the results back to either Prometheus or ES. And the Prometheus, from the Prometheus, we can monitor those, the metrics that it has re-ingested with a particular tag. We will be able to create a visualization to see how that particular metric is, looking with the lower bound and upper bound, baseline. So with that, let me quickly show you in the metrics UI how this looks like, right? So let's go back to our particular cap here, the dashboard that we have created. And delete this. Okay, let me open this one. Okay. So as you can see here, we have taken the CPU usage metric, and we have taken the historical data of this metric and ingested into our Edge AI module, or configure our Edge AI module to continuously monitor these metrics by looking at historical data, train itself, and understand the patterns, and create these lower and upper bounds. We increase the time window here. So what are we plotting here? What we are plotting here is, okay, for this metric, what is the baseline, right? So the baseline is between the upper bound and lower bound. So the bottom green one is the lower bound, and the orange one is the upper bound, and the blue one is the actual. So if I click on the CPU application actual, so this is the actual metric, and anything is above the upper bound with a certain factor, anomaly factor. Let's say either it's like 25% on top of upper bound, or 35%, 50%. You can configure that, and as soon as it observes that the metric is suddenly spiked more than the upper bound after learning the historical data and understanding the patterns and creating this baseline. So it plots the anomaly. It takes that as an anomaly and it plots that. So that's what you're showing here. So using these anomaly key attributes, we can create an alert and send the notification to either a ticketing system or our AIOps solution. With that, what I would like to add here is there is a deep dive session on machine learning. I highly encourage you guys to check it out. Our colleagues are going to cover a deep dive, information into our ML capabilities within our AIOps solution. Additionally, so as I briefly talked about CFX-DX, our CloudFabrix data exchange module, it is very powerful tool, and for any AIOps solutions, when you deploy it, one of the key challenges integrating with the different data sources, right? So you're talking about different third-party vendor metric sources, log sources, CMDB sources, and they'll have different interfaces, different provides the information in different formats. So it is very one of the pain area part of any AIOps deployment. So but our CFX-DX module, it simplifies with any of these data integrations. So there is a particular deep dive session into the CFX-DX. So I highly recommend you guys to check it out. So with that, let me go back to our observability solution UI again. And so finally, I briefly wanted to touch upon our edge discovery module. Let me click on our edge connector here. So this is another important module within our observability solution, which discovers and collects the inventory data of all of the IT assets, which can consist of virtual infrastructure, operating system, network devices like switches, routers, firewalls, and load balancers, storage arrays, and cloud infrastructures like AWS and Azure and whatnot, right? So it uses the standard protocol interfaces like depends on the endpoints and assets, either SNMP or SSH through CLI, WMI for any Windows integration, and HTTP RESTful APIs for any management systems like vCenter or Hyper-V or AWS and whatnot. And so it collects the asset inventory, and we provide that all the discovered assets in the reports. And so part of this is that the inventory data is one of the very key data source to keep track of all of the assets that you have and how they have been configured. So using these data sources to generate, what we do is we use all of these inventory data, metrics and logs and traces data. What we do is we help you to generate periodic reports for monthly or quarterly reviews or assessments. So if I go back here, click on the report. I just wanted to show one sample report here. So this is these are one of the some of the reports which are generated automatically through schedule or periodically. Depends on how you configure them. If I click on the asset inventory report, so it shows what are the monitored endpoints, and what are the different hosts and their attributes, IP address, host name, and the type of operating system they're running on, whether they're bare metal or virtual and whatnot, and what are the software packages have been installed on these assets, and what are software licenses if you have any licensed softwares installed, and what is the disk inventory, file system configuration, and your CPU inventory, what type of CPU you have, how many number of cores you have, the speed, and these are very detailed inventory data of all the assets that you have. With that, let me go back to the slides again. So that's pretty much covers all the components and modules of our observability in a box solution. So as we went through how our observability solution, it has the ability to monitor the entire application stack, right from the application services like web, app, DB, and the infrastructure components like OS, containers, and underlying virtual or bare metal application, bare metal infrastructure, either on-prem or public cloud. It has the direct integration with our AIOps solution. So for any alerts, for any metrics or logs or traces, we have the ability to integrate with our observability solution, pull in that information into our AIOps solution, and apply the much more advanced techniques like alert correlation and pull in some real-time metrics during the incident time, and show and provide that visibility into the operations team to help them to quickly identify the root cause and address the issue. So with that, let me quickly show what we have in our AIOps solution. Let me click here. So this is one of our a key capability within our AIOps solution. What we call it as outcomes. Within that, you have the ability to define these in application stacks, and you can define what are the key KPIs you would like to get into this aggregated view, right? Okay, so while our observability solution allows to monitor or observe the business critical application stack end to end, right? So our AIOps solution provides a single pane of glass aggregated view of an entire application stack in a single pane. We call it as a radar view. So here we have created one such aggregated view for the FedClean application stack. So these are some of the key KPI that we have selected to elevate their status, for the operations team. So what we are looking at is one of the elevated KPI is availability and overall response time. What are the alerts? If there are any active alerts here, if any changes happen to the FedClean application stack by pulling the information from CMDB sources like ServiceNow change management systems. If I open this, what we are seeing is the application performance information for the pet clinic in application here. So when I click on, when I drill down, what it is providing you it is providing you the complete view of the top-down application stack or different layers which are participating within the pet clinic applications, right? So I was talking about web service, it has a web service, database service, and underlying virtualization infrastructure stack. So when I click on that, it is showing what are the other layers has the some kind of activity within this incident timeline, right? So whatever the radar view that the bar that we are looking at is within the related to the incident time frame. So when I click on the when I expand the web service here, so within the web service, you have the multi-dimensions here, right? So you have the alerts within the web service. If there are any alerts during this time period, there is one alert. I think this alert is coming from the web service itself, saying that the response time is slow. And under the web service, there is a matrix, and within the matrix, it has observed some anomalies with the disk usage and memory usage, and some anomalies from the logs. So there are some errors generated within the web layer. And if you expand the database service, there is an alert saying that there is a high CPU and memory usage. And based on the data that it has got, what it is pointing here is it is pointing that this could be the probable root cause, which could be impacting the application performance or the application response time and the slowness. So this is how it will help the operations team by providing the end-to-end view of application stack for the cross-functional teams to which will help them to collaborate better and helps in resolving the incident much quicker. So with that, let me go back to the slides. And let me talk about how this can be deployed and what are the different options available. So this can be deployed on-prem. We provide a prepackaged OVF, or it can be deployed on a public cloud like AWS or Azure or GCPs. Just to add a few points here, so we built our observability solution based on microservices and distributed architecture. So all modules can be deployed in a single box in a simple as a simple solution, or it can be deployed in a distributed manner. So it is highly scalable vertically or horizontally in a distributed fashion based on the size of the environment. So with that, I hope this session is very useful and informative to all of you. So thank you so much for your time. Please feel free to ask if you have any questions.
Thanks, Fani.